I'm going to talk about trigonometric identities now. And the first thing is, as you see on this paper, you need to memorize the quotient identities, reciprocal identities, and Pythagorean identities, all shown on page 725. I will give these on the next test, cofunction identities and the negative angle identities. They're not as common. These you'll use periodically and many times with trig functions. So we're going to start with one of the two types of problems. There are actually two types of things I want to focus on in this section. And the first one is a problem like this. It's to find cosine and tangent when you're given the sine and you're given a restriction. I'm going to write the word restriction under here to sort of emphasize what that means. When we get to it in a few moments at the end, we have to make sure that the cosine and the sine are both within between 0, or the angle is between 0 and 90 degrees. What that tells us is in the first quadrant where this is, we can see that sine is positive, but we know that in that quadrant, cosine and tangent are both positive. So if we get answers that are positive and negative, we can disregard the negative and only use the positive answer. So what we're going to do with this is think about what this tells us here. And there's two ways to think about it. So remember that the sine of any angle is the y value over the radius coming out from the center of the circle, or the origin. And it makes for a right triangle. And it makes a right triangle like this. If this is the angle theta, we end up with a right angle here. And the value for y is here, that's the 1. And the radius underneath it is the 2, and the radius is the hypotenuse. So if this is the center and we're going out like this, we come to this point, and this becomes 2. In order to find the cosine or the tangent, we need the x value here. For this angle, the opposite over the hypotenuse was the sine. The adjacent over the hypotenuse will give us the cosine, and the adjacent over the opposite will give us the tangent. So our place to start is to find out this x value. And since this is a right triangle, we can use the Pythagorean theorem. That's one of the methods to do. In fact, there's two methods to do. So let's follow continuing here with the Pythagorean theorem. I'll consider this method 1 here right now, and first method. We're going to do that x squared plus y squared is equal to r squared, or a squared plus b squared is c squared. And in this case, x is this one, so we'll call that one y. X squared plus 1 squared is equal to r squared. X squared plus 1. Oh, wait a minute, I forgot to put that. That's 2. 2 squared. So 2 squared is 4. Subtract the 1 on both sides. X squared is equal to 3. And then when we take the square root of both sides, we say that x is equal to plus 4 minus the square root of 3, because negative root 3 times negative root 3 would give us a 3, and positive root 3 times positive root 3 is a 3, so we have to account for both. So that tells us now that the cosine here, cosine of theta, is going to be the x value over the r. Cosine of theta is going to be either positive or negative. It's going to be the square root of 3 over 2, or it's going to be the negative square root of 3 over 2. But from this restriction, we know we're in the first quadrant and cosine is only positive. So therefore, this is the cosine. Now, before we get into the tangent, let's take a look at an alternate method here. And in certain problems, this becomes essential because it's not possible to determine the y and the r or the x and the r. So in an alternate method like this, what we're going to do is recognize that the sine squared theta plus cosine, so I meant to write cosine there, cosine squared theta is equal to 1. This is the Pythagorean identity. And using part of this, we can get cosine. So 1/2 squared Because don't forget that what this really is sine theta squared. But math convention for decades and more than that, I don't even know when it began, is that you don't put the square on the outside, you put it in with sine. And many people feel that's really doesn't make sense, but it's the way everybody does it in the math community. So if you don't do it that way, it's going to be seen as strange, so you have to get used to it pretty much. But it does mean 1/2 squared plus cosine squared theta equals 1. That's 1/4 plus cosine squared theta equals 1. Subtract 1/4 from both sides. Cosine squared theta is 1 minus 1/4. That's 3/4. Take the square root of both sides, and the cosine of theta is equal to plus or minus the square root of 3 over the square root of 4. I don't need to write square root of 4. Square root of 4 is 2. So we now have the cosine of theta is positive square root of 3 or negative square root of 3. We're right back over here. It's positive square root of 3, which fits this restriction, and negative square root of 3 does not fit that restriction. So we're right back into this issue here. But now we know what it is. Either method, using the Pythagorean theorem, because you can identify 2 of the parts of it, or using the Pythagorean identity, either of those will work to give you the cosine. So now we know that. Now we need to find tangent of theta. To do that, we should just simply come back up to here. Now that we know that's the square root of 3, we recognize that the tangent of theta is the y value over the x value. Okay? So we can actually think of it in 2 ways here. And let me do both of them, because the sine theta over cosine theta, I should have started with this, because the tangent of theta equals sine theta over cosine theta is one of the quotient identities. And cotangent theta is the reciprocal of that. So if I think of it as y and x, and I know that y is 1 and that the x is square root of 3, I can say it's 1 over the square root of 3. And I'll get back to that in a moment. Or if I do sine of theta over cosine theta, I can say that with the sine being 1 over 2 and the cosine at square root of 3 over 2, oh, well, if I multiply top and bottom by 2 over 1 and 2 over 1, the 2's cancel, and so I get 1 over square root of 3. So I get the same thing. And I'd be done, except that in the math community, you are not allowed to leave the square root on the bottom. So we must rationalize it. So the tangent of theta is equal to the square root of 3 over 3. Either method, either immediately going to y and x from 1 there, and square root of 3, we now know that x is the positive square root of 3, we can put that there. We can go immediately to this, or we can do this method. Now we know that the cosine of theta is that the tangent of theta is that, square root of 3 over 2 and square root of 3 over 3. All right. Let's put that one aside. I'm going to do a couple more that are like this, where there's a restriction and you have something. On the test, you're going to have 2 of these types of problems. Not 4. Looks like 4 if I hold it like that, but it's 2. So you'll have 2, so you'll have to make sure you are comfortable with how to do it. Let's do this one. Secant of theta is -3, find the tangent of theta, and now this tells us we're in the 3rd quadrant. In the 3rd quadrant, cosine is negative, sine is negative, but because 2 negatives cancel out, the tangent is positive. Secant is the reciprocal of cosine, therefore it's negative. Now, we could maybe use that, but frankly, the system with the Pythagorean identity is easier in this case, so we're going to use that. Tangent and secant both are connected by the Pythagorean identity. And so what I'm going to do with that is I'm going to write it out. Tangent squared theta plus 1 equals the secant squared theta. Okay? No problem. So here's my first step. I'm just going to write that out. And then I'm going to put -3 in here. So I'm going to say tangent squared theta plus 1 is equal to -3 being squared. And so the rest of this is really just algebra. 9 minus 1 minus 1 really easy algebra working on an equation like this. Get down to here, and now we take the square root of both of them. Tangent squared theta plus or minus the square root of 8. And so the square and square root cancel. We now know that the tangent of theta is equal to plus or minus 2 root 2, because you never can leave it like that. So you have to do the square root of 4 times 2, and the square root of 4 is a 2, so there you are. So make sure you're comfortable with doing that every time, because I would not mark this as correct. Well, we know that the tangent is positive or negative from this, but we know from here in the second quadrant the tangent is positive, therefore we can disregard the negative and we can say that the tangent of theta is equal to 2 square root of 2. Okay. So I'll put a little note here. Disregard the negative because tangent is positive in third quadrant. Yeah, there's a little reminder about that. So that restriction is really different, really important, because negative 2 root 2 would have meant that there would be an angle in either the second quadrant or fourth quadrant, or both of them, that would satisfy this. All right. Actually, the negative 3, because that's cosecant reciprocal, means that, and cosecant's only negative in the second quadrant, it means you'd be stuck having to work with the second quadrant. Maybe not stuck, but you'd have to use that quadrant's angle. Let's take a look at C. Okay, so here's a third example. And now we're dealing with cosecant and cosine. And we're in the fourth quadrant. So think about what it means for the fourth quadrant. In the fourth quadrant, over here, our cosine is positive, our sine is negative, and tangent is therefore negative because it's a combination of those two. And the reciprocals of those always match the same sign. So let's think about how we're going to deal with this one. So the cosecant theta is negative 5 root 3, or negative 5 over 3 rather. This is a case where you want to remember that the cosecant of an angle is the same as 1 over sine theta. I can't seem to write sine theta. But these are reciprocals, so all you really have to do, instead of putting 1 over that, is just flip it. So if the cosecant of theta is negative 5 over 3, that means that the sine of theta is automatically negative 3 over 5. So we're just going to go from the cosecant to the sine by using the reciprocal. Very helpful thing for that. What we have to determine now, let's think about this. So I'll call this sort of like step 1 here. Now for step 2, let's determine, is it negative 3 over 5 or 3 over negative 5? So let's think about what this means. The key is that the sine is y over r. And the r is always positive because it's a distance radius. So remember that what's happening here, if you do the circle like this, and it's actually, I guess you could say, it's not the unit circle. But what we're saying here is that the y value is either positive 3 and then a negative 5, but wait a minute, we can't really go a negative 5 on this. We could go a negative on the axis, but we can't go negative diagonally. So therefore, we're going negative 3, and then and the radius is going out 5. So somewhere around here is our x value. So this is negative 3, and this is positive 5, and somewhere out here is our x. Oh, wait a minute, not there. Somewhere here is the x. And we need to figure out how much that is. So what we know then, that the y has to be negative, we say, nope, not that. So if we know that the sine of theta is negative 3 on top over 5, we now know, as a result, that y equals negative 3 and r equals 5. And that allows us to do x squared plus y squared equals r squared. So that's x squared plus negative 3 squared equals 5 squared. X squared plus 9 equals 16 x squared. X squared 16. Oh, not 16. I'm getting ahead of myself. This is a 25. That's 9. When I subtract 9 from 25, I get that 16. So x is equal to plus or minus 4. Do the square root there. But we already saw both visually here from the fact that we're in a fourth quadrant. I guess we could have done this with the 5 over here. But we know from this that we're there in the fourth quadrant, so we know that the x has to be positive. So x is equal to 4. And we're trying to find the cosine. So the fourth step here, cosine of theta is going to be the x value over the r. So the cosine of theta is going to be equal to 4 over 5. And the 4 is positive because of the fact that we're in that fourth quadrant. So think about what this tells you. In this case, you're using a reciprocal identity. So extracting from that the y and the r, using the Pythagorean theorem to get the x value, determining based on the quadrant to use the positive, and then using that x over the radius that we already determined back here. So think about these three problems. In this one, using the reciprocal identity and using the Pythagorean theorem are the two key things to help you get that answer. In this problem, you're using a Pythagorean identity, okay? And then again using the restriction to determine what you're at. In this problem, you can either use the Pythagorean theorem or the Pythagorean identity to get to here. And at that point, then you can use the quotient identity or the simple y over x explanation or definition of tangent in order to get the tangent. So there are numerous different things you can use to solve these. Your job is to be ready for them and then recognize what to use or play with different ones until you get something that works. Notice that none of these did we ever have to find out what the angle amount was. Not necessary in any of these. That'll come up in a later lesson. In fact, when we do section 12.5, I believe that one will talk about solving the equations with trigonometric equations in order to find the actual angle. And we'll work on that when we get to that. Okay, where we're going next now is the second type of problem I want to emphasize, and is to simply simplify. We're not going to get a fraction amount, a decimal amount, or an angle amount. What we're going to do is take what's here and simplify it down until there's nothing more we can do. So we're going to use the identities we know to do anything that's possible until there's no more chance of anything that makes it smaller. So let's start with looking at this one here. For tangent squared theta times cosecant squared theta minus 1, and all of that divided by secant squared theta. I'm going to call this like step 1 on this one, where just writing it correctly down on paper is pretty important. The second step is going to be using some of the identities here. I could either do them separately or I can do two of them. So over here I'm going to write down what I'm doing. I am going to use a quotient identity to change tangent to the sine squared theta over cosine theta. Sine squared theta over cosine. And notice that the fact that squared doesn't stop you from using the basic identities. Cosecant squared theta, now I'm going to use a reciprocal identity to change cosecant squared theta to 1 over sine squared theta. So since that's multiplying there between those, I'll put the dot this time. I don't really need to, but it helps to keep them now that I'm separating them as fractions. And that's still take away 1, and all of that is divided by, oh, now wait a minute, we can use a reciprocal identity here. because secant is 1 over cosine squared theta. So we're going to do that one twice. Okay, now that we have done all of these, let's see what happens. Aha! Cancel that out. And so the third thing, canceling. And that's going to give us 1 over cosine squared theta minus 1 over 1 over cosine squared theta. So now we're going to work with a fraction. So what we have here, so fourth, I'm going to call this fraction work. Like them or not, fractions and understanding how to use fractions is really essential. So I'm going to do 1 over cosine squared theta minus 1. And I can divide by 1 over cosine squared theta. And I can put that there. But don't forget that if I divide by a fraction, I should be changing that instead to multiplying by the reciprocal of that fraction. Cosine squared theta over 1, even though I really don't need that. So, because I don't need it, I'll just sort of cross it out. So dividing by this is the same as multiplying by the reciprocal. Then the fifth step here is I'm going to distribute it. So that times this, and that times this. So cosine squared theta times this one gives me cosine squared theta over cosine squared theta. Cosine squared theta times -1 is negative or minus cosine squared theta. Okay. Well, that's 1. So let's simplify. 1 minus cosine squared theta, and that's just simplify. And that's what we're supposed to do, but there's one more thing we can do. You should recognize here that because sine squared theta plus cosine squared theta equals 1, the Pythagorean identity, if you subtract cosine squared theta from both sides, this is a Pythagorean identity. So the seventh thing is just to say simply sine squared theta, and using Pythagorean identity. Oh, that's small. Oh, that's a little small. And that's the thing to recognize. Let me just make that very explicit. Because we know that the sine squared theta plus the cosine squared theta equals 1, we can subtract cosine squared theta from both sides. So now sine squared theta is here by itself, and this is 1. Take away the cosine squared theta. You can do the same thing with sine. If I subtract sine from both sides, the cosine squared theta equals 1 minus the sine squared theta. There are times that it's useful to you this way. There's times it's useful to you where it's cosine squared theta equals 1 minus sine squared theta. Sometimes it's useful as just the main one, like that. Either way, if it's useful, then use it. But here it has been simplified. We started with this, and we're able to do quotient ID, reciprocal ID, do fraction work, and distribute, and get it to where we could use a Pythagorean identity to make it as simple as is possible. We can't do more with it than that. Okay, let's do another one. We're going to do 3, 4 of these right now, because this is also another important thing. On the test that I'll give on this section, there will be 2 questions on this as well. 2 questions on the other type of problem, 2 questions on this type of problem. And it could be of various types, so you have to be ready to use any of those identities there. All right, now, get some notes in this one. Okay, I have an explanation written. Here it is to remind myself what to do. Okay. We're going to simplify this one. I'm going to call this my first step, writing it out carefully and seeing I have all the negatives in the right places. So my second thing that I'm going to do, I'll put over here the things I'm going to do, is I'm going to use the, for secant and sine. For the secant, I can use the reciprocal identity to get it to a sine or a cosine. By the way, that's one of the things to generally, rule of thumb, not always needed, but 90% of the time, make any secants, cosecants, and cotangents into the other three. And any tangents, usually if you make them into sine over cosine, that simplifies too. So get everything into sines and cosines. And most of the time, that's when you can easily start easily canceling things out. So I'm going to use the reciprocal identity here and make that 1 over cosine theta divided by sine theta times, well, 1 minus the cosine squared theta is just what we were talking about in the last problem. That's a Pythagorean identity. Pythagorean identity. So 2 identities here we can use right at the bat. The third thing now, well, let's just simply do some canceling. Because remember that sine squared theta is the same thing as sine theta times sine theta. Just like x squared is x times x. Or if you saw 7 squared, you could write it as 49, but 7 squared also means 7 times 7. You wouldn't usually do that, but that's the meaning of it. Here you would do that, because by splitting that up, we can now cancel that. So cancel sine theta. And that means now we have 1 over cosine theta times sine theta. And let's multiply those. Sine times 1. And 1 on the bottom here would be 1 times cosine if we wanted to write it. We certainly don't need to. Sine of theta over cosine theta. So that's really multiply. Oh, and that one you should recognize as quotient identity. That's simply tangent of theta. So quotient identity. And that would be our answer. That would be as simplified as we can get it. That looks a little bit messy. Well, once you do the things that you're able to, reciprocal, Pythagorean ID, do the basic algebra, basic math that's there, you then get down to a quotient ID. Okay, let's do another one. Now, simplify cosine of pi over 2 minus theta, in parentheses, times the cotangent of theta. So, first, here's the problem, and now we'll put the things over here that I'll do. So the first thing, in the second part here, I am going to do a couple of things. This is something that seems weird. I don't mean for you to have to memorize the cofunction identities or formulas, but you do need to recognize them so that if needed, you could use them. And in the list of cofunction identities back on that page, the one that I told you to start off with, on page 725, you can see that's a cofunction. And this automatically becomes the sine of theta. That's because this is 90 degrees. Around the unit circle, wherever cosine is, if you then move 90 degrees, if you're at 90 degrees and you subtract whatever the angle is from it, you'll actually get, or pi over 2, 90 degrees, then you'll get the sine of theta. It's not as common to use, but here is a place where it is used. So that becomes that, and that's the cofunction identity. And then the cotangent of theta as a quotient identity, quotient here, is the cosine of theta over the sine of theta. Oh, really nice. Now we cancel, because we can see here the sines will cancel. So simply cancel, and we get the cosine of theta. Well, you can't really get any simpler than that, so that's pretty much it there. That is the answer to that. You recognize 2 different identities, use them, and it becomes very easy to cancel something out. Sometimes something that looks more complicated, doesn't look that complicated, it becomes very easy. As long as you recognize what to do or try some of the things that look like they would make sense. Okay, now, here, this problem, we have 1 over sine squared theta minus cosine over sine squared. In fact, this one could have been written as cotangent squared. So if it were, we would make cotangent theta, totangent squared theta, as cosine squared theta over sine squared theta, and squaring it would do the same thing, because that's cosine theta over sine theta times cosine theta over sine theta, so that makes cosine squared and sine squared. So we have step 1, step 2, we're just multiplying it out, squaring it. Sine squared theta minus cosine squared theta over sine squared theta. So that's all we're doing here. Third thing, we have two fractions, and they have the same denominators. So we can just simply subtract the fractions. 1 over cosine squared theta over sine squared theta. So this is fractions, or subtract fractions. Something you've done many, many times. You just might not recognize that with tangent or with trigonometric functions, you can do the same thing. You really can. You can still do the same thing here. So that's what we're going to do. We're going to subtract fractions here. Now, at this point, you should recognize this as a Pythagorean identity. So, therefore, let's do it. 1 minus cosine squared theta is sine squared theta. So we have sine squared theta for that, and it's being divided by sine squared theta. So our fifth step is simply that. You simplify or reduce it down to 1. So we got to here by using 1 minus cosine squared theta equals sine squared theta, that Pythagorean identity. And then 1, this is simplifying, or you could call it divide, or you could call it reduce. There's a number of acceptable things. Simplify at this point is still a good generic term for just cleaning it up and getting it to the simpler thing. So if that means that this one, again, it's not that complicated, but it looks like you're going to have to do some things. Well, you do just a couple of things and everything just cancels. It becomes simply 1. So all of these, you're doing the various different basic identities that this section teaches, and with some fraction work or basic equation work while doing it. And you will have 2 problems like these where you'll be simplifying a more complicated, or this type of sometimes complicated, sometimes not that complicated expression. And you'll have 2 like the other problem where you'll be finding a trig function like cosine or tangent or one of the other ones, and have to limit your answers based on the quadrant that you're in. All right, so be ready for those things from section 12.1.